Visitors to the Space Operations Center of the European Space Agency in Darmstadt, Germany, have the unique opportunity to see a satellite that is a true twin of one already launched. It may not have its solar wings, but the Rosetta engineering model is identical in practically all respects to the probe on its way to rendezvous with a comet. Since leaving Earth in 2004, the spacecraft has travelled over 3 billion kilometres, a third of its journey towards comet 67P Churyumov-Gerasimenko. Circling the Sun, it has so far swung by Earth twice and Mars once, each time accelerating to reach its target. Each close encounter with a planet is a major milestone. The spacecraft must respond precisely to instructions, and having a fully functional spacecraft at its disposal allows the mission team to investigate on Earth any issues aboard the actual space probe. Such maneuvers are critical for us. We must navigate extremely precisely with a precision in the order of 10 kilometers around the planets to obtain the required gravitational acceleration. Before each maneuver, the flight teams rehearse procedures many times. During these tests, we simulate all the upcoming operations. We rehearse and prepare all our actions. We practice to identify all the eventual problems that could arise, to have a team that can react immediately and efficiently. These planetary flybys, with a third and final one of Earth in November 2009, are exciting events mobilizing everyone's attention. However, they are only steps towards the final goal, and everyone imagines the historic moment in January 2014 when Rosetta reaches its destination.
For the first time we will fly, not just fly by a comet for a few hours, but fly in the vicinity of a comet for more than 1.5 years. So this will allow the scientists to collect data over an entire cycle of a lifetime of a comet, from very far distance to the Sun down to its closest distance.
The mission scientists will, of course, be the most thrilled at the prospect of studying at close quarters an object which probably has not changed since the formation of the solar system 4.5 billion years ago.
By studying comets, we actually have the opportunity to look into the past of the solar system and can then see how the solar system had formed, what material was available from the solar nebula and formed into the solar system.
Rosetta will investigate how the comet loses water and dust as it approaches the Sun. But the mission's greatest challenge will be to deploy a small lander called flyby to analyze the comet's surface composition and to drill into the icy nucleus to collect and analyze samples.
It's not just the water, it's also, we know that there are organics on comets. And so some of the organics that were there in the beginning of the Earth, so when life started, might have come from comets.
Although this culmination of the mission is still 6 years away, the flight dynamics engineers at ESOC are already preparing each phase, with 2 intervening flybys which will provide valuable experience.
We have 2 encounters with asteroids, but the position of the asteroid is not known very accurately. In these cases, we have to go with even optical navigation. We have to take pictures of the asteroids as we approach them to assess accurately where they are.
Science observations are being finalized for the 5th of September next, when Rosetta will be obtaining exceptional close-up views of a small asteroid some 20 kilometers in size called Steins.
We are passing by at about 800 kilometers distance, so a comparison would be like standing in Paris and just barely resolving my house in the middle of Germany in Lindau. So it doesn't sound so impressive when you say 14 meters a pixel, but when you add up with 800 kilometers, it's still, you can't expect to do much better.
And with the probe passing Lutetia, a much larger asteroid, in 2010, Rosetta truly will be making the most of this 10-year historic odyssey.